Hello world, welcome back to another Flash Learn devlog where I'm developing a Gen AI powered flashcard system like Anki. This week I've worked on a ton of under the hood improvements for my backend with some exciting development in the front end as well. First of all, I dove deep into the backend, finally tackling integration tests with the awesome Testcontainers package. This means a more reliable and robust system, which is always a huge win. Next up, error handling got a serious upgrade. No more vague error messages. I've implemented more precise and detailed error reporting, making debugging as a developer a whole lot easier. Shifting gears to the front end, forms got a huge boost. On the feature front, I'm thrilled to announce that the browser page is finally complete with filtering and searching capabilities. And finally, I've refined the web UI by incorporating dialogs to improve user experience. So without further ado, let's get into the details. Let's start with my integration test setup. I'm using the awesome Testcontainers package. It's widely used for doing integration and smoke tests and supports a ton of languages, including Golang. Last week, I adopted SQL for type-safe code generation for Go, which has been a huge productivity boost. However, SQL code gets complicated. Like, look at this one over here. It's huge. There are gonna be a lot of bugs. So what I want is a way to ensure that the proper behavior of complicated code like this is maintained. This is where the integration test comes in. So I'm going to show you how I'm using the Testcontainers package using a small little example over here. So over here, I have a simple insert function that's inserting a deck into the database. It first does some check on the name, then does a check on the description, and checks if the database is actually valid, and then actually does the insert operations. So how do I actually know that this works? Well, that's what the integration test is actually for. The reason I need an integration test and not a unit test is because I actually need the database in order to do these checks. A unit test would mean I have to mock the database and then somehow check using that mock that the insertions and the storage is actually happening, which is a lot of hassle. This way, I can just do none of that and just use Testcontainers to create the database. What Testcontainers is basically going to do is that it's going to create a connection to a temporary Postgres Docker container, and then I can use that for my tests. So over here, I'm checking the different ways the name could be invalid. So you can pass in an empty name, and then I'm going to check, hey, is this error message going to be returned? Which is supposed to be returned right over here. Yeah, so I can also check, hey, is it just a space, which is going to be filtered out when this line over here is run. So I test a lot of these error cases and then check whether each of them pass properly. And then I do this for all of my classes. And yeah, so this has been a really good lifesaver for me, because now I can be sure anytime that I'm extending the behaviors of any of my classes that none of the behaviors actually break, and the tests will catch when a behavior is inadvertently changing due to modifications. So this brings me to error handling. As you can see over here, when I'm checking for the deck name validity, if the deck name is not provided, or when the provided deck name is only space characters, it's going to be throwing this specific error, which is basically going to say, hey, you were supposed to give me a valid deck name, but it's empty. And then if the deck name is greater than the max allowable length, it's going to be like, hey, that's too long. And this is actually done for a lot of different types of checks. If I go into here, over here, you can see like the many different types of error messages that there are. And then what I do is these are going to be thrown by many different types of checks throughout the backend. What I do is I tie these in with an HTTP status code. So whenever I'm getting REST API requests and any of these errors come up, I can easily tie them in with a specific request. Like for example, if the database or table doesn't exist, something that went wrong in the backend, so these errors are going to be tied to the 500 code. Then an HTTP request comes in to fetch details about a specific deck or a specific card. But hold on, that thing doesn't exist. So it's gonna throw the status code, status not found, or 404. This is done for almost all the errors. The good thing is, whenever these are actually thrown, these error messages are going to go in the response body as well. So not only will you know what request code you're getting, you'll also know why you're getting that request code. As a developer, it makes my life a whole lot easier knowing what precise error is being thrown. as a user, it also makes my life easier because now I know, hey, if a deck name isn't being accepted, why isn't it being accepted? Is it because it's empty, or is it because there's a duplicate? So how does error handling actually benefit me as a user? Let's try and create a new deck. Previously, this deck form was shown as a separate page. Now it's just a simple little dialogue. Let's say that I'm feeling very lazy and I do not want to enter any deck name. I'm just going to click on submit, and as you can see, the form tells me you can't do that. Deck name has to be at least one character. And then deck description is showing a little check over here because the deck description is actually optional. So this entire check is actually done using a library called Zod. If I come over here to my code, yeah, so this is the Zod schema. As you can see here, for deck name, I'm defining that it has to be a string and it has minimum and maximum character limits. And for deck descriptions, I'm only setting a max deck description character limit. Anyway, so if any of these are not done properly, then an error message is shown for the specific field that we're working with. So in this case, I have to enter at least one character. So let's say that I do enter a name and I call it astronomy, if I can spell it correctly. All right, so astronomy, as you can see in the background over here, astronomy already exists. So this is actually not valid. So if I click on submit, I expect that even though this is showing a check right now, it will throw me an error. And it does. Over here, it says the deck name already exists. So how does this one work? Basically what happens over here on the right, as you can see the errors go, I return an error of 409 when the deck name is not unique. And this error message is actually caught over here. If I come over here, and this is the add deck function that's actually sending it, and the send deck request. And yeah, so if it was created successfully, I would get a 201 for insert and 204 for update. But since it wasn't, that means there was an error. So it will try to get the error message based on the text, and it comes to over here. And then it's going to first check for what type of status code got returned. So in our case, it was 409. And then it's going to say, hey, is this a deck name? If the response text includes a deck name, which is going to, if we come over here and say, yeah, so deck name, not unique. So if it finds deck name in a 409, that basically means that deck name already exists, and it throws this error. And then what happens is this error gets intercepted, and then it is properly tied in with the deck name text field. Previously, this error would be shown as like a toast pop-up, which is not right in my opinion. It should be exactly where you're actually entering the text itself. Let's say this is biology, and we have a deck name. This is a biology deck, and click on submit. It gets created and immediately updated, and you still get the toast when on success. All right, now let's talk about something a little bit more visually interesting to look at, and that is the browse page. Last week, browse page was implemented with only sorting functionality. This week, I extended the functionality by adding which columns you want to view. So over here, you can see a list of columns here. Let's say that I wanted to view source as well, and maybe flag, and then close this. So you can see the table has been updated to include those specific columns. You can also sort by these columns as well. So if I wanted to sort by source, you could do that. Say I wanted to search computer science cards, I can say deck :com full stop enter, and then all the computer science cards are showing up over here. What if I wanted to see what cards there are with the tags of data? I just type that, and then over here I can see the tags. All of them have the keyword data in them. I can also do created and modification time stuff. So if I wanted to see what cards I created today, so I can do created :0. So these are the two cards that I created today. What if I wanted to see what cards created yesterday? So I do created :1 full stop enter. So these are all the cards that were created yesterday. If I wanted to edit, let's say, what is PCA? So I can just double click on this and come over here and change it to maybe say what is principal component analysis, and then hit submit, and then it should be updated right over here. So what is principal component analysis? And the answer is this. So it has the previous tags. We can also update the tags too. So if I come in here and say maybe PCA as a tag is not right, we can do that and click submit. It gets removed. So that wraps up this week's devlog video. Next week I will be working on study mechanism and importing and exporting from Anki. If you guys like what you see and want to see more, look forward to new videos. Until then, catch you guys in the next one.